equals to negative 0.9. And from these three equations, equation 1, equation 2, and also equation 3, I can transform this into matrix equation. So, but before that, let me rewrite the three equations. So the first equation, negative 2.125y1 plus y2 equals to negative 1.2 y1 minus 2.125 y2 plus y3 equals to 0. And the last equation, y2 minus 2.125 y3 equals to 0.9. So in matrix form, the first matrix is the coefficient matrix. So negative 2.125. This one is 1. And the third equation, we don't have the y1 term. So the coefficient is 0. And then for the second column is the coefficients of y2. So this one is 1. And then negative 2.125. And then 1. And for the third column, it is the coefficient of y3. And for the first equation, we don't have y3 term, so the coefficient is 0. Then this one is 1. And the last equation is negative 2.125. And our variables is y1, y2, and y3 equals to, and the last matrix, the last vector is are the values of constant, negative 1.2, 0, and 0.9. So this is our matrix A, vector Y, and vector B. And if you can see this A matrix, this matrix A is a tridiagonal matrix. So to solve this system, to find the Y values, we can use Thomas algorithm. Thomas algorithm is used to solve the tridiagonal system. And this system is called tridiagonal system because this A matrix is a tridiagonal matrix. You may also use other methods such as Gaussian elimination, Cramer's rule, or etc. But if you use Thomas algorithm, it is much easier. Okay, before you use formulas in Thomas algorithm, let's identify the C, D, and E terms in this matrix A. Okay, as I have explained in my Thomas algorithms video, the main diagonal, this is the main diagonal. This is the D term. This is D1, D2, and D3. And the upper diagonal, this one, this is the upper diagonal. The diagonal above the main diagonal. So this is the value of E. We start with E1 and then this is E2. Okay, for the lower diagonal, that is the diagonal below the main diagonal, this one here, 1 and 1. And this one is the C term. And for C terms, we must start with C2. So this is C2 and this is C3. And for the vector B, this is our B terms. So this is B1 B2, and B3. To use Thomas algorithm, the first step is always to find the alpha I and beta I values. And these formulas will be used to find the alpha I and beta I. And these formulas also will be given in your final exam paper. So, first we need to find the alpha 1. So, alpha 1 is equals to D1. So, what is D1? D1 is negative 2.125. Negative 2.125. And then we need to find the beta 1. So, beta 1 is E1 over alpha 1. So, what is E1? E1 is 1. So, 1 over alpha 1 is negative 2.125. Okay, next we need to find alpha 2. Alpha 2 is D2. Please refer to this formula to find the alpha 2. D2 minus C2 beta 1. Okay, so, D2 is this one, negative 2.125. So, negative 2.125 minus C2. C2 is 1 times with beta 1. Beta 1 is this value, 1 over negative 2.125. And we can simplify this value by using calculator. And the value for alpha 2 is negative 1.6544. Okay, next, find the B2 value. B2 is E2 over alpha 2. So, E2 is 1. So, 1 over negative 1.6544. Okay, and maybe I can simplify this fraction into decimal. And the value of beta 2 is negative 0.6044. Okay, next, alpha 3 value. Alpha 3 is D3 minus C3 times with beta 2. So, D3 is negative 2.125. C3 is 1. Beta 2 is negative 0.6044. So, alpha 3 is equals to negative 1.5206. And then we can find the beta 3 value. Beta 3 is E3 over alpha 3. So, E3 is, what is E3? We don't have any E3 in A matrix. So, meaning that this E3 is undefined. So, this term here also undefined. We don't have any value for beta 3. So, we can stop until alpha 3 only. Alright, for the second step, find the WI values. And to find WI, we can use these formulas. And this formula also will be given in your final exam paper. So no need to memorize it. First, we need to find W1 value. And to find W1, please refer to this formula. B1 over alpha 1. And B1 is the element in B vector, in B matrix. This one here. So it is negative 1.2. So negative 1.2 over alpha 1. So alpha 1 is what? Alpha 1 is this value. So alpha 1 is negative 2.125. Negative 2.125. Okay, and simplify this value by using calculator. So W1 value is 0.5647. And next, find W2 value. To find W2, please refer to this formula. So B2 minus C2 W1 over alpha 2. So B2 is 0. 0 minus C2. C2 is what? C2 is 1. 1 times with W1. W1 is this value. 0.5647 over alpha 2. Alpha 2 is this value. Alpha 2 is negative 1.6544. So W2 value is 0.3413. Okay, next, find W3 value. W3 value is B3 minus C3 W2 over alpha 3. B3 is 0.9. 0.9 minus C3. C3 is 1. Times with W2. W2 is 0.3413 over alpha 3. Alpha 3 is this value. Alpha 3 is negative 1.5206. Oops, sorry guys. I just realized I made a mistake for B3 value. If you can see from my equation here, this one, B3 is supposed to be negative 0.9. So I forgot the negative sign in front of negative 0.9. So this one is supposed to be negative 0.9. And inside the matrix B also, I must put the negative sign here. Okay, so my B3 is negative 0.9. So my W3 is 0.8163. Okay, that's it for WI values. We don't have any value for W4 because if you substitute into the formula, W4 equals to B4 minus C4 W3 over alpha 4. And we don't have any value for B4, C4 and also alpha 4. So this W4 is undefined. So we can stop until W3 only.